My name is Godwin Ajaguma, representing Ebenco Global Link. And today we are presenting to you our thermal desorption unit, because we are into waste management system in Nigeria. At this moment, we would like to present to you the thermal desorption unit, that is the TDU, which we use for the treatment of waste, the oil-based mud cuttings. What I mean by that is the drilling cuttings that are retrieved from the drilling sites. That is what we process here. And I would like to present to you all the process we follow by introducing the components. First, we have, as you can see, we have the condensator, we have the reactor, we also have all the auxiliary components that make up a unit. Now I would like to present to you each of them, one after the other. On my left, we have the condensators. As you can see, this is a complete unit where all the gases are processed during operation. Here, as you can see, the other side, we have the reactor. This is the condensator. We have the filter unit. We have the outlet unit that goes to the skip, right and left, because we have two units here. The main reactor is one on my left and on my right. The process is but we come in with the mud. We have the inlet that goes to the reactor where the mud is processed. As you can see, also we have the burners that boils the cane drum. We have the inlet screw, and before the inlet screw, we have the shaker unit, and after the shaker unit, you can see the pond wall. That is where we store the oil-based mud. And the process of operation is simple and it's easy. The first thing we do is we have a unit that brings in the mud to a storage tank that is going to be installed here. We will take from this storage here, which is the mixer, into the shaker to separate the rough particles like the iron, metals, and the rest of it, waste clothes, waste goods, and the rest of it, to get a molten standard mud. The separation is done here, and you drive the motor, and it goes into the hopper. From the hopper, then it goes into the reactor where it is processed. And this time, there's a kind of setup temperature that will break down and do some separation. But naturally, The major work of this reactor is to heat up to a standard temperature. And after attaining that temperature, the heat will need to travel to the outlet. From the outlet to the filter, stage 1, and from the filter to the condensator, where we retrieve the base oil. And at that point, separation ought to take place, because as we all know, anything above 100 degrees centigrade, there is always a separation. Migration of heat. This heat contains both oil, water, and other gases. After attaining a level, what we do, we need to come to this point and open the valve and let the dry cotton go away through the screw, outlet screw. During this period, we have outlet screw 1, outlet screw 2, and this is the skid where the wastes are kept for sample test. Because according to standard, we do take sample of whatever we produce at this point for lab test, so I can attain the normal standard, which is less than 0.2 or less than 0.3 acceptable standard before disposal. However, that disposal is not done not until it is tested to know or to ascertain the level of oil content in the waste product. Because at this point, it's already at the powder stage. However, it's not at the powder stage, but yet there's still oil content, but there's a standard for it. There's a standard before it can be disposed. Then, the mud, as they come in, they are guided. How is this guided? It's guided by making sure that there is no spill around when bringing it in, and it is well protected in the pit. Yes, during operation, there is smoke that is normally emitted from the reactor, and that smoke exits from this point into which we call the quench. This quench takes in the smoke and converts it to steam, so that the pollution in the environment will be eliminated. As you can see, it travels from the red pipe down to unit 1, unit 2, and finally to the draft tank. These two tanks contain water. So the moment the unit starts running, the smoke travels right from inside the reactor down to tank 1, tank 2. Before going to the exhaust, which is this, it has turned to steam. So pollution is almost zero. At this point, it's zero. Because I know everybody will always ask, where does the smoke go? Now it is very clear. Before me here is a cooling tower, and you can see a lot of water in the tank. This water is used mainly for the condensator. And this condensator is the one that cools the hot air coming from the reactor, where the real exchange, where the real conversion is done. This is where the separation of gases and the water is carried out. Without this condensator, we cannot achieve anything. The hot water from the reactor goes into the condensator, from the condensator mixed up with the cold water. It's not a direct mix-up, but there's a kind of separation. The coldness is used to convert the hot air, so we can attain this goal of getting the oil, which is the base oil, from the mud-based cuttings. Yes, as you can see, we have two consoles. These consoles are the panels that controls each unit. This is for unit 2, as you can see, both of them. And this is for unit 1. At this point, we control every activity that goes on with the reactors. At this point, you can control the speed of the kiln drum, which carries the mud, which is a real reactor unit that processes everything. And at the same time, the condenser that controls the separation of the gases. All the motors are here. So this is the central memory of that TDU unit. So like these are for the kiln drums, the inlet and the outlet drives. The same thing for the other units. This is our monitoring unit for the burners. Should there be any failure during operation, you can view it right from here and control it. My name is Godwin Ajaguma.